Can you all stand by up? This is our agenda for today. We're going to start a new chapter. We're going to do two things today. So tiny there. Everyone ready? So around 1 hour, after we go for CC. Okay, we've come quite a long way in our journey for biology. So far we've spent a lot of time diving in the very microscopic level of the chemistry of biology. I'd like to just give a general outline of where we've gone so far. When we first started off, we talked about how atoms bond. We came across many different kinds of bondings and interactions, right? From hydrogen bonding, polar covalent bonds, non-polar covalent bonds, hydrophobic interactions. These are the things that hold atoms, molecules together. This is its structure. From there, once we know what holds everything together, we start going into the bigger things. The first biomolecule we went into is lipids. We spent quite a lot of time there on lipids. Primarily, we focus a lot of our attention on this particular lipid that's very special, that our frog is named after. Yeah? No, it's not what our frog is named after. It's a property that's named after. Our frog is called, the lipid is called phospholipid, and it's amphipathic, right? We also learn other kinds of lipids like triglyceride, as well as steroids. Yeah. As I was marking your work, I noticed one thing. Okay, a lot of you say that the presence of carboxyl group is what defines a lipid. Actually, that's not true. There are many things and other molecules that have the carboxyl group. 2 chapters down the road, you will see that proteins, and if we break it down into its amino acids, they also come with the carboxyl group. So it's not a defining factor. Okay? What's more defining is that lipids come with a lot of carbon and a lot of hydrogen and less oxygen. Okay? After that, we went to carbohydrates. And in carbohydrates, we've spent a lot of our attention on one particular molecule, sugar, and that was glucose. And you found, and now we learned that there's alpha or beta glucose. Depending on whether you are making use of alpha or beta glucose to build a polysaccharide, you get different structures. From starch, which consists of amylose, amylopectin, or cellulose, or glycogen. Okay? Today we're going to go into the next category of biomolecules. We call it nucleic acids. Okay? Nucleic acids. Nucleic acids, I think one form of nucleic acid that you may be very familiar with is your DNA. I believe this is the only biomolecule that you have not learned before in JH2. In JH2, you learn one more biomolecule, which is the next chapter, proteins. Yeah? So this was JH2, and then we're going to amp it up a bit. But today we're going to dive into a new biomolecule that you've never encountered before, but you've heard before. DNA. You've heard of DNA. DNA, if I were to break down the word, stands for deoxyribonucleic acid. Okay? And that's where we're going to spend this particular chapter in. Yes, Hasid, you got hand raised? Okay. Okay, so that's where we're going to spend our time today. First and foremost, I just put up in Google Classroom a link. Okay, I just put in Google Classroom a link. If you click on that, you will find the structure of the DNA. My challenge is still open. If anyone still wants to give it a try, you could build this entire structure, all the parts. Yeah? Students have done it before. I'm going to find the record time, and you see if you want to beat it. Okay? This is the structure we're going to spend some time analyzing and understanding what it's made up of. It's a crazy large structure. Okay, so I'd like you to at least pull out this model at the side so that you can make reference to it. Really big, yeah? But it looks quite familiar, right? For some reason, every time we talk about biology and then you have to choose a logo, they will choose like bang, this DNA molecule. Yeah? So we're going to understand and make sense of what DNA is today. But before we can dive so deep, we need to talk about what DNA is made up of. But actually, maybe let's go one step back. You know the function of DNA. Have you ever heard the function of DNA before? Or it's just something that you've heard of but you don't quite know what it is, or what's its purpose? Anyone heard of the function of DNA before? Okay, I hear stuff. Why it holds stuff? Zoe said the word genetic. Anything else? Something brewing here? Sorry, yeah? No. Yes. Genetic information. Have you heard this before? When did you hear this before? Primary school. Oh, goodness. When they say the word genetic information, what does it even mean to you? Sorry, what? Babies. Yes.
What makes you unique from other people?
What makes you unique? Something about uniqueness. Anything else? Yes. Okay. Serene says that this information is a bunch of codes that tells the body how to first create more cells. If I were to put it very simply in layman terms, DNA, yes, it contains genetic information. We'll find out more about this a few more chapters down the road. But to put it very simply, think of DNA as a recipe book inside your cells. Okay? It is like a recipe book. You know, it's not a recipe. Looks like it's oh, it's recipe, right? Okay. Recipe book. It's really like a recipe book. And later on, as we go a little bit deeper, we'll see that actually it even has a code of its own. It carries information like a recipe book to tell the cells what kind of things you can build in the body. So everything that's in your body has its information inside the DNA to tell the cell how you're going to build it. For example, you have digestive enzymes, you have your hair, your eye color, everything is written in a code inside the DNA. That's why it's so powerful. So today we're going to try to make sense of what DNA is, what it's made of, and the more we know, the more we'll be able to understand how it makes us unique, makes us who we are, makes us special. Today we're going to start first with a lot of vocabulary. To understand this particular topic under biomolecules, we need to imbue ourselves with a lot of vocab first. I'd like you first to go to class activity 1.4. You see a whole bunch of words. These words are words that you're going to encounter in this topic. And they, quite scaringly, they look very similar. A lot of them start with nu, then behind is either tide or side. Okay? So, the first part of today's lesson, we're going to spend some time making sense of the vocabulary. Our first activity, I'd like you to try yourself, sorry, not yourself, try in a group. You can work in pairs or work in threes, to try to find out how all these terms relate to each other. Because in reality, although these terms are very similar looking, because they are very related to each other. Some of them look almost the same. Only difference is in one alphabet. What makes them different just by changing the alphabet? Okay? So this is what we'll do. Yes?
For the second row, why is the whole word same?
Oh, okay. So thanks for asking. This second row, you have to look at it as this section over here, okay? So it's not, we're not asking you to compare nucleoside, 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 nucleoside. No, it is nucleoside phosphate, nucleoside monophosphate, diphosphate, triphosphate. Okay? This is an entire word by itself. So there are 3 rows of words. Okay. I'd like you now, I'm going to give you around 15 minutes. You'll work in your pairs. Oh no. Okay, we'll work in our pairs or groups of 3. To try to find out how all these terms relate to each other. Then in a while, we will share with each other how the terms relate to each other. Okay? You may use any resource you want. You can look at your textbook, you can Google online. Some of you may find the information faster than others. Okay, we'll try to make sense of how all these terms relate to each other. Okay? And last but not least, maybe to give you a little bit more context, all these words relate to one thing. It relates to the basic unit of DNA. If starch is made up of glucose, proteins made up of amino acids, DNA is made up of these things. So as you research, understand that you are looking at the basic unit, not the entire DNA yet. Okay, so we'll start small. We have 15 minutes. I'll give you some time to try to make sense of all this. You may copy images to paste in that blank below, and in a while we will share with each other our findings. not really used to store information. It's imagine you have a library. That's DNA. What RNA is, right, is like a photocopied version of DNA that I can use and break out of the nucleus.
So it's only of the DNA. But it's not the one that's being used, it's the one that is brought out for us to use.
It's also, yeah, it's brought up for other enzymes or whatnot to read. So that's why I would say RNA is a little bit more temporary. It's literally like a photocopy worksheet.
But DNA is the original.
Yeah, DNA is yes. I've heard about it before. I would say that is one way to look at it. Around 3 more chapters down the road, you'll go to cells. And inside the cell, right, you will see how all the biomolecules come together to build the entire cell. Okay, how? Do you need more time?
Yes.
No.
I can send you guys the answers.
Okay, this one is Google skills, right? You know where to search. Actually, you type the correct words, everything will come up somewhere. Everyone go to Google Images. Go to Google Images. What do you type? Some of you found the jackpot. Go to Google Images. What do you type? You're going to type nucleoside versus nucleotide in Google Images. Okay, I think this is what you may find. Nucleotide versus nucleoside. Okay. Teach you how to research. Typically for biology, if I want to learn anything about structure, actually the first place I go is not the or, I will go to images. Because that gives me a very visual way of understanding the topic. You click on that, See the first image on the top left gives a summary of how everything relates to each other. You try? You have you Googled it? I give you some time to have a look. Okay. You did a lot of hard work, but does it align with what you see here? Okay. Many of you did a lot of hard work. You researched each word, found each image, but is it similar? Is it similar to what you found? I quite like this succinct way of representing the differences. You can search the image yourself and you can add it into your class activity. Maybe a better one. Yeah, maybe there are others that you can find. Some is quite good. This one is quite clear. Yeah, okay, go to Google, you should be able to find a lot of things. It's the same. I said it's not so glitchy. Just now that one had like a yellow rectangle, right? Okay. As you touch up your notes, for those that find it difficult to understand, just going to very quickly run through the basics. Okay? This will help you understand this chapter a lot better. Okay. Number one. You'll see on the screen that they color coded certain things. Red, yellow, blue. But the green is the word. Yeah, okay, so you see red stuff and then yellow and then blue. Okay, so baseline at the moment, I'd like you to understand that we're going to work with 3 building blocks. 3 things come together to build our basic unit that will be used to build DNA, or as you see later, RNA. Number 1, actually at the core of it all is a sugar. Okay, you see this oxygen, and then you see something like this is a pentagon, is that what we call it? Okay, remember, this is a carbon skeleton. Every corner represents a carbon, and this corner, we call it carbon number 1, carbon number 2, carbon number 3, carbon number 4. Branch out from carbon number 4 is another point, carbon number 5, and then it goes this way, and then there's the oxygen, and then it will bond to other stuff. Okay? You'll find that carbon number 3, there is always an OH, hydroxyl group. As I was marking on work, I see some students spell it as hydroxide group. It's not hydroxide group, it's hydroxyl group. Okay? And carbon number 2 is the one that if you've done your research, you notice that it can be different. You could find at carbon number 2 either an OH, or you could find just an H bonded to carbon number 2. Okay? So that's layer number 1. I see. We call this a sugar. But what kind of sugar? We call it a pentose sugar. How do you know why do you call it a sugar? You can see a lot of hydroxyl groups, right? kind of like a sugar. Pentose because made of 5 carbons. Right, so it's a pentose sugar. Another form of sugar other than glucose. Tyson, yeah?
Does it matter if it's OH or HO?
It does. Okay, so now let's layer another layer. This is a pentose sugar. Whether it's OH or H, it will mean it is a different kind of sugar. Yes?
HO, not H.
Oh, say again.
Does it matter if it's written as like OH or HO? For the
Oh, okay, like over here, is it?
Yeah.
Okay. Tyson is asking, does it matter if we write it as OH or like that, is it? Okay. Typically, we will read left to right. Okay? Typically, we read left to right. And also, you want to make sure there is bonded to the oxygen. I would say that you doing this is not necessarily wrong. Okay? Because you've made it bond to oxygen. That's the key thing. However, I tend to write it like that because we see hydroxyl group usually as OH, right? Okay?
But then
Yes.
on like all the diagrams they're written as HO for the rest of the time.
So I'm saying that it's not wrong per se. The fact that they can still bond it to oxygen is okay. Yeah. But personally, I would write it like that. It's easier to see the hydroxyl group. Then remember it is polar. Remember it's hydrophilic. We write it in the same pattern so that you can spot these patterns fast. Okay. So as I was saying, okay, it can either be bonded to a hydroxyl group at carbon 2 or hydrogen. It really depends. If it's bonded to a hydroxyl group, we call it a use blue. We call it a ribose sugar. So pentose sugar is like a broader term. There are many different kinds of pentose sugar. Right? If you were to find that there's OH at carbon 2, we call it ribose sugar. If it's an H bonded at carbon 2, we call it a deoxyribose sugar. Deoxy because I have removed oxygen. Okay? So if there's a hydrogen here, if we remove that oxygen, it's called deoxyribose sugar. Okay, so that's the first thing we need to understand. That part of the monomer of DNA is actually a sugar. Yes, Shanice.
Is a pentose sugar like a monomer?
It's not a monomer. It is part of the monomer.
So it's not your complete. The monomer is not your complete.
Yeah, the monomer is not yet complete. That's a good question. Okay?
Ribose sugar is.
Still okay? Okay, next thing we'll add. Next thing we'll add. You'll find on the top right hand corner at carbon 1, this is where you can bond to something called a base. Okay, something called a base. There are 2 classes of bases. You see on the right hand side of the screen, there are purines and pyrimidines. 2 classes of bases. You'll find that also, if you look at the 2 classes, purines consist of 2 rings of carbon and nitrogen. Pyrimidines consist of 1 ring of carbon and nitrogen. You'll also find that there's a name to all these structures. On the top right hand corner, you see A, and you see adenine, guanine. Bottom for pyrimidine, you see cytosine, uracil, and thymine. These are just the names of the bases. I do need you to remember this. Okay? No, I do need you. Okay, so you need to remember this. I'm now going, you will often see in the textbook that sometimes we short form it. Rather than say adenine, I say A. Rather than guanine, I say G. So if you were to see these alphabets, understand that I'm trying to represent the bases. Yes?
So we need to be able to learn to draw it and identify it.
Okay, so that's the good news. You don't need to know how to draw it. Okay?
But you need to know to identify it. So you must know the difference between like A and B.
Okay, so if I don't need you to be able to draw it right, it means I don't need you to really identify either. Okay? I do need you to be able to identify on this level that purines have 2 rings, pyrimidines have 1 ring. That's all I need you to identify. Okay? Let me teach you a cheat method, or rather what your senior taught me how she remembers this. Okay? So you need to remember that purines consist of two kinds. Adenine, guanine, pyrimidines, cytosine, uracil, and thymine. Okay, so this is how your senior taught me how to remember. Okay, a pyramid is sharp. Right? Because got point, right? And therefore it will cut you. That's what the senior told me. Okay? A pyramid is sharp. Therefore it will cut you. Then you look at pyramids, right? Pyramids also don't consist of two pyramids joined together, and it's just single by itself. So that's how I use it to remember. This is like a pyramid if you look from the top, with many sides. Okay, usually a pyramid only 4 sides. Okay? So pyramids are sharp, so they will cut. Okay, then the remaining Ag is for purines. That's what your senior taught me. I find it quite useful. Okay, what does this mean for you? It means to say, at this location here, at carbon number 1, I could either bond it to A, or a G, or a C, or a U, or a T. Either one, only one at any one point in time. Okay, bear with me. We need to review ourselves this vocab before we move on. So at this point over here, when you write base, you can only choose one to bond to. So for example, right, here I sort of built one already. Okay, so here I have a sugar bonded to a base. This is G. At any one point in time, you can only have one base bonded. Okay, only one of the alphabets can be used. Right, we'll come to this later. Okay, that's the second part. You have come across the first word, therefore, that you're supposed to classify. What do we call this? You have a sugar and a base. And we call this you've done your research. Okay? Okay, it's called a nucleoside. A nucleoside consists of a sugar, which could be a ribose sugar or deoxyribose sugar, bonded to a base. Let me write this in black. Nucleoside. Therefore, don't be alarmed if you see additional words in front of this. If you were to see the word ribonucleoside, it just means that they're trying to tell you that this nucleoside is made up of this ribose sugar. If you see the word deoxyribonucleoside, it means that the core sugar is a sugar with an H at carbon 2. Yes. Carbon 2, yes. Oh. Yeah. Yeah, I'm going to layer one more layer. You see on the top left hand corner, and carbon number 5, you can bond other things. I think today we'll just stop there. Top left hand corner. Okay, you see all the P's? Yeah? Yes, that's it.
Nucleoside means the ribose sugar or deoxyribonucleic sugar connected to a base, right?
Correct.
Not just
Yeah. Okay, just asks, the idea of a nucleoside is that there is a sugar, number 1, and a base together, number 2. So a nucleoside is 1 plus 2. A ribonucleoside means, right, that they want to be very specific, tell you that number 1 is 1A. Okay? If they use deoxyribonucleoside, means that it is 1P. Yes?
And you said it shows that between the pentose sugar and the base is a glycosidic bond.
Yeah.
So it's like you must lose There's no like O there. There's no oxygen there. How are you gonna take away a
Oh, that's a good point. Okay, if I'm not wrong, there is supposed to be an OH at the top right hand corner.
so there's a hydroxyl group there?
Yeah. Okay, but I did not draw it out for you. Okay, we do not need to know this particular section how the glycosidic bond forms. But you're very sharp. There should be, I think, a OH there, just like a sugar.
Like all the time in every pentose sugar there will be OH.
Just a sugar by itself. I think so. If you go and search a pentose sugar, you see there's OH there. Okay, just like glucose. Each carbon got one hydroxyl group coming out. See, okay? So this very last layer will be this. You see that you can add up to 3 numbers of phosphate groups. That's what they call it, right? I'm going to simplify on the whiteboard. I'm not going to draw all the other parts. Just going to put a P. Okay? Every P I put means a phosphate group. So if I were to have one phosphate group, you'll see the word mono in front. Okay? If I were to have a 2 phosphate group, it will mean di. Okay, if I have 3 phosphate group, it will mean tri. This is tri. Okay. Oh, so the last one right nucleotide. What is nucleotide? Okay, so then the question is, I think we have a few more words. What is a nucleotide? Okay, what's a nucleotide? I want to just circle a nucleotide. Okay, this is what a nucleotide is. A nucleotide is a sugar a nucleotide consists of a sugar, a base, and just one phosphate group. Okay, that's what nucleotide would be. Nucleotide. Okay. I have some good news for you. In the event all of this terminology is really complicated, the very least you need to know is this one over here. Okay, understand that a nucleotide consists of a sugar, any one of these 5 bases, and just one phosphate group. Because a nucleotide is the monomer of the DNA. It is like the glucose of starch, it is like the amino acid of protein. A nucleotide is what repeats itself in a DNA. Okay? So what's RNA? So if this box over here is a nucleotide, if I want to subset it, there are deoxyribonucleotide or ribonucleotide. If I subset it. But what's the key difference? Now that you understand the purpose of adding this in front. If I say deoxyribonucleotide versus ribonucleotide, what would be the key difference between the two? Okay, what's bonded carbon 2? That's the only difference. So a deoxyribonucleotide would be a P plus a sugar that has an H plus a base. If we say ribonucleotide, it would be a P plus a sugar that has OH bonded to a base. So now we see the purpose of adding this deoxyribo in front or ribo in front. It just gives additional information about the nature of the sugar. Okay, that's its only purpose. So someone, when you ask what's the difference between DNA and RNA? So if I were to write RNA out in full, RNA stands for ribonucleic acid. RNA, the monomer is ribonucleotide. DNA, the monomer will be deoxyribonucleotide. That's why a mind map will be needed for this particular first part. Okay, I will stop here today because there's information overload. You take some time now to join the links, draw the links together, and then I'll go around and clarify if you don't quite understand the difference between certain terminologies. But now we spend some time linking the words together, making sense of what means what. Oh, okay, that's a good question. Okay, the information only comes in, right, when we have many nucleotides linked together. Because you see, right, if each nucleotide, the base can be either or line, I could write a sentence, in a sense, right? It could be, I could write a sequence of like a sentence, like A, G, C, E, right? And that sentence, right, is what provides the information. Yes. Okay, so a nucleoside phosphate, I would say it's just a more, it's like an umbrella term for all these groups. Okay, actually, you notice it's exactly the same, right? May I ask a question? What is the difference between nucleotide and nucleoside monophosphate? Nucleotide and nucleoside monophosphate. What is the difference? It's the same, just two ways of saying the same thing. Okay? Nucleoside monophosphate. Nucleoside monophosphate. Actually, it's just a nucleotide. So, the reason why we show you all the spread of terms, so that if you were to see it, you don't get a root shock. Because they all look very similar. Yes? Okay, so next question. Nucleoside phosphate. Then there's a mono, there's a di, there's a tri. Okay, think of this as just a more general term. That it is bonded to phosphate group or groups. Okay, so this is the umbrella for all these fellas, different fellas. Yes? Yes, there are two ways of looking at it. Yes? You either have a P or no P, right? Yeah. Why do we have so many versions of this? You notice each word just means whether you take out one part or add one part in. Yeah. It is to be a little bit more specific when we come down to actually building things. I'll upfront tell you that the what you see the most is this over here. This is what you see the most. Any more questions? You take your time to digest this today. That's all we'll do for today. Be ambitious. Yes, Ishan? Okay. So the definition of a nucleotide is that, yes, it contains one. Yes. What is it? If the monomer of DNA is deoxyribonucleotide, the monomer of RNA is the ribonucleotide version, the one that does not contain OH. So you're asking what it is or what is it for? Yeah. Okay. The reason why we call it nucleic acid is the polymer version of it. Yeah, so if we add many together, it's like, when we add many glucose together, we don't call it polyglucose, we call it like a starch or all the different versions. So that's what we will call it, poly version. That's it. Okay, so you've heard DNA, but what's RNA? Okay, if I put it very simply, if the DNA is like a recipe book, RNA, in a sense, is like a photocopied page of the recipe book. That's how I'm going to put it as an analogy for now. Okay? I give you a reason why. Do you know where you can find DNA? The nucleus, right? The nucleus is like the library. You store all the recipe books there. But you wouldn't want a the student to go in and take the recipe book out, and then there's a chance you might damage the recipe book. Then I cannot make muffins anymore. Right? So actually, I'll is an ingenious way of solving this problem. Instead, how about we photocopy pages of the recipe book that we really want? Then we take it out of the library and we use that to bake muffins or bake cakes. I don't know if my analogy makes sense, but hopefully when we come to that chapter, you'll see the purpose of RNA. You're right, RNA is shorter than DNA. Yeah? DNA is extremely long, it's an entire book. RNA is right, it's like a page of the book, a photocopy page of the book. Yeah? Okay, that's all for today. You take your time to tidy your notes. Oh, like one more key, is it? I don't know, I've never seen it. Yes. Good question. Right. There's a theory that we don't know. There's a theory. People don't quite know where to classify rice. What was their source? Today they are all sure of original micro applications floating around. Giving a copy of the original. So there's a lot of theory of where life came from because the RNA is working. But not all viruses are RNA. Some are DNA. So yeah, we give you the overview. Okay, so now we will go into CC period. Right, time to open the mailbox. You watched Blue's Clues before? Not nobody watched Blue's Clues before. Remember Blue's Clues like our mailbox one? Okay, we've got a lot of mail today. We should come up with a jingle, right, for mailbox opening. You know, like jingle, then every time open, right, got sound. Hey, you just learn the coding, right? Put the sensor here. Every time open it up, right, got one sound. Okay, could I get someone up, maybe help? We can sort this. Yeah, because there are some personal messages that are going to be out. So the leaf are all the personal messages. Ooh, okay, so there are quite a number of personal messages. Secretary, Aronika, help me sort. Okay, so we have a lot of leaves. Leaves are personal messages, typical. You can read a male woman and a leaf. Okay, then we have a lot of toast. Toast is bread, is what we're going to read. Toast. Get it? A toast to the class. Oh, one more leaf. Okay, and then we have some personal thoughts. Okay, so we have some personal thoughts, and then we have toast to the class. Oh, I thought you want to read. Okay, a toast to the class. I got one from here. Sorry? Ayo, thank you. Ayo, whoever who gave me this, thank you so much. Okay, a toast to the class. Maybe I would like to invite someone up. Or Christine, you want to nominate someone to come out and read the toast to the class? Oh, okay, you come up. Okay, you have a look. What it says. Then got feels, the message will come out. Okay, I do the first one to set the tone. Okay? I love O2. Yeah, so that's the first one. Let me say, I heart CO2. Wow, I wasn't here Mr. Arm's talk. Can you give a face the class?
Why do we have so many class pets? Untouchable frog, coral cat times 4, untouchable crab.
Oh, why do we have so many class pets?
Where is Swaggy frog? Yeah, where is Swaggy frog? Where is he died?
Or maybe Christine, you give it up first. Yeah. Okay, I read some personal thoughts. Remember, if you write this here, right, means is to share on. Okay, it's no longer. Okay, so this is okay to hear. I'm not sure what happened during Mr. Arm's talk. Okay, but this message says, after Mr. Arm's talk, I disagree that the youth is an excuse to be wrong. Okay, I need to think. I disagree that youth is an excuse to be wrong. Youth is not an excuse to be wrong. Do you agree? Oh, okay. So this person thinks that youth is not an excuse to be wrong. I don't know what Islam said. But I like to think youth is a time where we explore. Can we read the last one? Okay, maybe we go around. Those with the toes, you can shout out loud the messages that you received. The toes to the class. Okay, go ahead.
I really like the way our class always steps up and tries their best to help out in some way or another. I really believe we are already cultivating a really nice and positive environment, and I'm grateful for everyone in our class for this.
Thank you again. Sion?
Hey everyone, I'd like to say I'm proud of you all for already making lots of friends, but try not to stick to the same people every time. Nama Islam inshallah. And Mr. Tan, if you recognize our handwriting, will say Jeez
Okay, thanks, Sion. Valentina?
I was in the reverse order.
Where the flower? Oh. Okay. Zoe says thank you. Thanks, Valentina. Lucy?
This class is amazing, love you guys. And then wrote something for the teachers. I like the amount of resources you're given, like videos and slides, so thank you for that. And would like to praise the comms for their hard work.
I can say as a teacher, I actually don't know what's happening in all the comms. But what I see is on the surface, but a lot of power goes into it, so I thank you all for that. Keller, are you next?
Yeah.
Hey, when I say this with gusto, Come on, Keller.
Super friendly. I was scared at first because I thought O2 would be very competitive and in terms of grades, but I'm actually quite relieved.
It's the handwriting that
I don't know.
it's so good that you can't read it.
Yeah.
Okay.
You should end it with a bunch. Just like, I don't know.
Yeah, but we sound like that.
Yeah.
I love O2 and heart shape.
Okay, we love you too, Keller.
Yes, I know.
Thank you, Keller. Who's next? Okay, Santosh has one.
I'm glad and grateful that our class is so positive. How am I supposed to? In light of being close contact, also happy that our class is so is.
You need me to read it for you.
Oh, it's Zoe, is it?
It's mine.
Okay, Zoe will read her toast to the class.
I'm so
You
sorry.
can be in my class for 2 years. You can read my
I'm
class.
so sorry.
I'm glad and grateful that our class is so positive, even in light of being close contact. Sorry, go Heidi.
Close contact in what sense? Okay, go on.
Also happy that our class is so close knit, even though that isn't really a good thing now. But yeah.
As long as you don't hug each other or see each other's seats. Next, anyone else? Where are the other toasts? Suri, you have a toast? Okay, a toast to the class from Suri.
So many people in our class always step up to lead and take initiatives and contribute ideas, and I honestly find that so admirable. O2 is so cool.
Yeah. Thank you. Any more toasts? No more toasts? Okay, then I feel I have a thought bubble. Okay. I'm personally very thankful for the class dynamic that our class has made over just the past few weeks. I feel like I'm able to connect well with everyone in class. It makes me so happy that everyone is quite comfortable to talk and share more about themselves. And I just really find it so encouraging that everyone is so amazingly friendly. Thank you for the teachers as well, because all our teachers are unique and weird. But in a good way. A lovely way. Wow, nice it. Okay, this last one I don't understand what it means. People do memorize Soviet anthem notes.
Hey, a bit too big.
It's a history student thing, I don't know what it means. Okay, thank you for the first round of our mailbox. We see when we will open the mailbox again, but feel free to continue to add notes of positive toast, a toast to the class, or a personal thought that you may have, or maybe a personal note to someone that's made a difference to you. Today, for the rest of CCE, I'd like to do something with all of you. Okay, with the remaining time left, okay, 15 minutes, we are going to try something. Or maybe if we don't have time, we can do it after school. Okay, yeah, to let you know that today, next door everywhere, they are watching part 2 of the Green Links Malayan Tiger. We will do that next Monday. Yes. Okay, we will do that next week. I do have a slot next week, but today I want to talk about something that is more, there's something that recently happened, yeah? Okay, we look to the screen over here. What do you see? You see orientation? Yeah. Anything else you see? You see a flag? Anything else you see? Bags? Anything else? Okay, you see a cleaner? Okay. As I observed this particular lane, that old auntie cleaner, she walked down the entire lane. Nobody saw or acknowledged her. Yeah. She walked past, and it's as though she didn't exist. It's as though she was invisible. Okay, this was this morning. I saw 2 elderly aunties mopping the entire atrium. Almost immediately after she mopped, a bunch of J students ran down and then went for PE. And then the entire floor was left with footmarks. They recleaned the entire thing. I spoke to one of the aunties, and she said that actually their reporting time is not supposed to be so early. She needs to come the same time as you guys will come. But recently she's been coming at around 6 a.m. Some come at 5 plus, because she tells me she wants to clean the toilets so that when you come, it will be dry and you can use it safely. She says that this is outside of work time. She doesn't clock in those hours. She comes in just so that she can do that. And I asked her if it's tougher in this time for her. She said yes. But then she said, isn't the whole of Singapore going through this tough time together? But at the same time, that hurts me. Because as much as we are going through this together, this elderly cleaner walked by and nobody quite noticed her at all. No hello, no greetings, and I sincerely hope we are not like these students. Just by noticing them, it makes a big world of a difference. When I spoke to Auntie this morning, she was her entire face lit up, and we had a conversation going on. I don't think we have enough time, or whether you can do this, but these few weeks, this entire term, they've been working very hard. I found out that there are 8 cleaners in this entire school. You see 3 just come just now? Yeah? So they came outside because they saw on the list that this is one class, ours, needs to be clean. I look at their list, there were 8 other classes they need to thoroughly clean. Ours was the priority today. 8 other classes, that means also to say that there were other classes that needed to be deep clean. And you saw that there were 3 elderly, 1 uncle and 2 aunties. There are only 8 cleaners in this school. 2 have fallen ill, have fallen sick from working really hard. So that means to say today they are left with 6. And that's why they couldn't clean our classroom this morning. My heart really feel very pain. Yeah? I hope, all I ask of you is to don't make them invisible. If you make them invisible, they'll feel invisible. Yeah? So I bought a carton of this. It is sugar-free. Right? It's sugar-free. But I would like our class to be the one to do it. Okay? So this is what we'll do. We have 10 minutes. I don't know whether you can find any uncles or aunties. But in groups of 3 or 2, let's go and find an uncle or auntie and we pass a drink to them. Yeah? Say maybe a good thank you on behalf of our class. Maybe on behalf of the school. I honestly think this is just a very short and a gesture that it doesn't quite repay what we are doing on a daily basis, but it may make a small difference. And I think perhaps you want to say hello to them, perhaps a hi. There may be a language barrier, but I think certain gestures go beyond languages. Actions speak louder than words. So I don't know how fast you can find cleaners, but therefore we have some leftovers I cannot find. Our aim is to find as many cleaners as possible, to give it to them and say, is that okay? But beyond this, as a class, if you want to do anything more for cleaners, let's think about it. Huh? And your groups of 2 or 3, find some friends. Okay, come, maybe you want to spread yourselves out. Okay, but come back in time for math lesson, okay? Alright, let's go. Oh yes, please. Oops. Yeah, one there.